Welcome back. We're going to talk a little bit here about chemistry, matter, and energy. Chemistry, we will study matter, which is all the stuff in the universe, for lack of a better word, and energy. So we'll talk about how that stuff, that matter, can change and what happens when it changes. So we call matter anything that occupies space and has mass. Remember, space is volume. And mass is a measurement of how much matter there is, and it's measured on the balance. Another new term for us will be substance. This is matter with a uniform and unchanging composition. The word uniform meaning it's the same throughout, right? So all of the elements on the periodic table are substances. They're all the same. So if I have a sample of hydrogen, what I mean by that is if I have a sample of hydrogen, no matter where I draw the hydrogen from in that sample, it will always be composed of one proton, right? Same thing with a compound like water, right? No matter whether if I have a cup of water, no matter if I look at a molecule of water at the top or the bottom of the cup, it always has the same properties. It's always 2 hydrogen and 1 oxygen. You probably learned in middle school a little bit about the states of matter. So solid has a definite shape and a definite volume. We want to be able to also draw solid particles. So solid particles are going to be circles that are very close together. Liquid will be particles that have a definite volume or take the shape of their container. So they can slide past each other. So they're still circles, but now there's a little bit of room between them where they can slide past each other. And gas, these particles spread out a lot further, so they're going to have a lot of empty space between them. But these particles are also shown as circles like that. So you want to also draw those into your notes as well. A new term here, vapor. So not all gases are called vapor. Vapor is specifically a substance that's normally a solid or liquid, but has been at room temperature, but has now been turned to gas at other conditions. So we call it nitrogen gas because it's a gas at room temperature. We call it hydrogen gas because it's a gas at room temperature. But we call it water vapor because water is a liquid at room temperature. All substances, we can talk about their physical properties and their chemical properties. Physical properties are properties we can observe without changing the substance. So I can observe color without changing. I can observe the temperature without changing the substance. I can observe the density without changing the composition of the substance. Same thing with odor, melting point, boiling point. Okay? Also ability to conduct electricity. So down below in the table here, you see some of the different physical properties we have for substances, things like their color, their state of matter at a certain temperature, their melting point, their boiling point, and their density. Chemical properties, on the other hand, describe how substances can combine or react with another substance. So you have to actually change the substance from one substance to another in order to observe a chemical property. So for example, if you think of burning a piece of paper, burning is a chemical property. To observe that paper burns, you actually have to burn it, which means it's no longer paper at the end of that process. So I like this table here. It talks about copper, right? So physical properties of copper, its color, how it can be shaped in different ways, how it can conduct heat and electricity. Chemical properties, they're all talking about ways it reacts to form new substances. So closely related to the idea of a physical property is a physical change. Okay, a physical change, again, is changing the substance in such a way that you're not changing what it is. So if you think about water, right, water can be moved from one container to another. You're kind of physically changing it, but you're not, it's still water, right? If you take a sheet of paper and you cut it up or smash it up, it's still made up of the same cellulose material that it was before you cut it or smash it, as opposed to chemical change, which we'll talk about in a minute. One thing that's tricky with physical change are all these things down below here, right? And these are all called phase changes. So one thing that will help you is both phase changes and physical changes start with the same letters there. And this is a little hard because water, when you think about water boiling, right, it no longer looks the same, but it's still H2O, right? And that's what makes it a physical change. We're just spreading out the water molecules so that we can no longer see them, which is a hard idea. But all of these physical changes here are, all these phase changes here, are physical changes. We'll talk a little bit later in the year about sublime and deposit a little more. But sublime is when you go directly from a solid to a gas, like dry ice. And deposition or depositing is the reverse of that. You go directly from a gas to a solid. These are also phase changes. So chemical change, like I said before, you're going to be changing the substance. So these words here often pertain to a chemical change, decomposing, exploding, corroding, rusting, tarnishing, fermenting, burning. It's often a little bit of a challenge to tell the difference between a physical or chemical change, so we can apply our claim evidence reasoning model to this. So if you take a look at this first one here, right, here's some water boiling. Take a minute to see if you can pause the video and see if you can write your claim, your evidence, your reasoning. Remember, your claim for this is very simple. I'll help you out. It's going to be boiling water is a chemical change or boiling water is a physical change. Evidence is observation, and then reasoning is your explanation. How'd you do? Here's what I would suggest. Claim water boiling is a physical change. Evidence, bubbles forming, steam above the water, right? Reasoning, again, this is tying in the science idea, and reasoning can say that boiling results in changing water from a liquid to a gas, but the water remains H2O, right? And we need a little more explanation. Maybe we would draw a picture to kind of help explain this. But this is a real brief little synopsis of water being a physical change. Here's another one for you. Again, you can pause then and fill that out. How'd you do? Burning is a chemical change. The paper turned black. Smoke was produced. Again, we're talking about observations here with our evidence. And then the reasoning, the original substance changed into something else, which usually indicates a chemical change. Not always easy to tell the difference between a physical and a chemical change, but so you're often not 100% sure, but you want to be able to talk about what your evidence is and why you think that. And that's a little bit of the introduction to substances, physical change, and chemical